Hi, my name's Yogi. I have met some of y'all. Who am I? Yeah, before I proceed, I'm going to actually talk about some of the upcoming stuff. So I'm just going to put up that one.
Yeah.
So
I love Spring.
my name's Yogi. I'm an engineer. I've been a Spring developer for close to a decade, I guess now. And I've been an open source user and contributor. I work as a senior platform architect with Pivotal. I've actually been working with engineers from Globe as well in recent times. And my first ever visit, my maiden visit to Manila was actually coming to Globe for the POC last year.
Yeah.
That went off well.
Yeah, we remember you.
So that was quite pleasant actually. The weather was nice, and yeah, there was no volcanic eruption that time, so it was good. So in past, I've actually worked for Barclays, BlackRock, and Standard Chartered Bank, predominantly financial sector. But at Pivotal, I work with a variety of clients like telco, much as yourself, as well as banking services and all. Yeah, I am living in Singapore, and I like to travel. So far, I've gone to 26 cities in the world, about 9 countries, over 2 continents. I do look forward to actually adding more to that. So before we get on to the supply chain security, what exactly is the software supply chain? Anyone wants to take a stab at it?
Software supply chain.
Not gonna lie, this is the first time I heard it.
Yeah, I mean it's not like an industry prevalent term or anything, but if you come to think of it, everything that you do, like as a developer, as an engineer, right? It goes through a flow and eventually ends up being in a production environment, right? So you have a code.
That's nice.
I don't think I have to explain that, right? I'm going to take a guess at how to say that properly. Menangari?
Yeah.
Right.
Yeah.
So that's the fun bit, right? And that, I think, is your software supply chain. It's basically how you're taking your ideas through your code and through to production as working systems, right? That whatever happens in between that Menangari is the software supply chain. And here, I mean, you can do security at many levels, like, as Jerome mentioned about learning the processes or learning the behavior of an application at runtime and sort of baselining what is good, and then sort of going back to see if there are any abnormalities. And that is one way of doing protection. Then you have the AST kind of things, the RAST kind of things that can provide you with some intelligence. Here, I'm very specifically talking about this bit, the middle bit, which in the DevOps world, it's controllable. This is something that you can actually make a difference in without massive investments of time or skills. So, I mean, what is that something? So you got a code, you compile it, you run some tests on it, it goes through some scanning, an artifact is created, the artifact is posted into repository, it goes into a deployment environment, and voila, you have your application up and running. Sound familiar?
Yes,
of course.
Am I missing anything?
Spot on.
Not quite. You have to observe it, right? That's how you learn, and you feedback those things into your code again, and you go through the cycle. Am I missing anything yet?
Well, of course, yeah.
Dependencies coming from external repositories, right? The code that was not written by you. All sorts of jars, all sorts of NPM modules, Python, packages, Ruby gems, all those things, right?
Yeah, right.
Or something lower level, operating system libraries. Not written by you. They do have vulnerabilities. I don't have to remind about Heartbleed and Mad Cow, right? So those were vulnerabilities that were not even in your application. They were actually at the operating system level, but your applications did get impacted by it. So when you look at your software supply chain, you have to look at all those aspects. So in this thing, let's first understand about the build and how do you get a secure and a consistent build. A consistent build, you would have your dependencies externalized, your configs are externalized, any sort of secrets should be externalized. You will leverage more sort of feature flags, and you will have good coding practices like remediating any potential cross-site scripting challenges or SQL injections and many more, right? So people leveraging some sort of memory leaks to do remote code execution or taking control or shell kind of libraries that might be downloaded in your application. So all those potential things, right, are something that you have to think about when you're actually writing code or using something from outside, right? But that is not the end of it. On the other side, you should have a very consistent packaging. So if Globe as an organization, right, if you're going to have, let's say, hundreds of applications, right, all of them may be written in Java, may be written in some language. What is the most prevalent language in Globe?
Probably Java.
Java? And do you all use Spring Boot a lot, or it's like mostly core Java?
Yeah, I don't still use Spring Boot.
Yes. Or the original Spring.
Or yeah, Java E.
Yeah, you do have Java E, and no two Java E packages look similar, correct?
Yeah.
Every EAR is different. Sometimes somebody would package a configuration file in the jar, somebody would actually package it in the EAR itself, and somebody would actually package it in the WAR file. Does that sound familiar?
Yes.
Yeah. So the thing is that getting that consistency, right, is very, very important from a DevOps perspective as well as security perspective. So every time, let's say one of the libraries that you have rendered, right, one of the dependencies you have used, may be used by hundreds of applications. It could be as simple as a logging library that has a potential of causing remote code execution. So now, when it comes to remediating that, you're looking at hundreds of applications that needs remediation, because every application uses a logging library, isn't it?
Correct.
So if you don't have a consistent build, you can't have a standardized solution as well for it. Does that make sense?
Mm-hmm. Yeah.
How about the runtime patches? You're using a certain version of Java, it is vulnerable, and it needs to be patched. You have hundreds of applications that need to be patched. That becomes a mini project of its own. Am I in the right pin code?
Yes.
Yeah.
Yeah. And adding runtime monitoring agents itself. During packaging or during your application execution instruction, you've missed out a certain agent that is used for like performance monitoring or security monitoring or some other monitoring, right? It's an agent that is required by Globe to be there. Happens? Does happen?
I'm not so sure. I guess, yeah.
Well, I have seen instances where organizations require the agent to be there, but developers just miss it as part of their application installation instruction, or by human error it was left out, right? Or somehow it got deleted on the machine and now the application just won't come up. And all these things are from real world experiences, not like something hypothetical. They do happen. So what you see on the left side, and I hope you're seeing the dependency should be externalized on the left side of your screen.
Yes.
Yeah. These things are something that you can actually sort of remediate through good coding practices. There is a lot of human factor involved in it. There is a skilling up required in it. There is no tool that will actually sort of, cover this whole thing 100%. Yes, you can have static code analyzers which would actually tell you, hey, you have a hard-coded value here, or this is like a wrong code path, or this is a potential problem. Yes, you will have those. But it's very, very difficult to, even for static code analyzers, to know what is a secret, what is a configuration, and what is just another string constant. It's pretty difficult for them to do, right? So this is something that you can remediate through test-driven development, and most of all, pair programming. Because when you're pair programming, you have an extremely fast feedback loop. You have a person who's sitting right next to you, who's looking at the code with you. You are writing, she is actually looking. And then after 40 minutes, you switch. She's writing, you are looking. That kind of a feedback, it's very difficult of course, it takes a little bit of practice to work in pairs, but with that little bit of practice, you prevent a lot of problems. So many times while doing my applications and deliveries, I mean, without even knowing that we are doing pair programming, I'm like, okay, my code is not working. I would just tap on the shoulder of my boss and I'm like, hey, can you come and look at this one? He's not even touching the keyboard. But you're like, okay, this line, it doesn't look right. Let's move this over, move this around, or let's use another API. And that's it. I mean, it just worked. So that kind of fast feedback loop actually helps you in remediating those problems, the ones on the left. While the stuff on the right, there is a good pattern to it, right? Establishing, consistent patterns, patching the runtimes, adding agents. All these things, they are known patterns, and this is what exactly build packs do. How many of you all have heard about build packs? Show of hands. Oh, one person, far in the room.
You showed it to me when you were here. That's why I heard about it. I heard it from you, actually.
I would have put you as an exception.
In the galaxy.
So build packs has been our native way of building and deploying application in our Pivotal Application Services product or Cloud Foundry. Actually, it's an open source product, Cloud Foundry, which actually used build packs. The technology was originated somewhere in Heroku, and of course they opened it up, and it's a great technology to allow you to build applications in any language, and just give it up to the platform to package it and run it, and it will do it consistently. So no matter whether it is one application or 1,000 application, you will have the exact same consistent packaging, because it's an automated process. It is not a process that every individual or a new project or an application is adopting. So what do build packs actually offer? They support like most common enterprise frameworks and runtimes, right? Java, .NET, Node.js, Ruby, Go, PHP, Python, everything. Everything in that is actually supported. You have a build pack for each of those languages and frameworks. Then it has, especially we have over like 350 Fortune 500 customers who have actually been using Cloud Foundry, and they have been building and deploying, if not like 100,000 applications, tens of thousands of applications, I would say, at least. So they have actually seen the results of using build packs at scale. And earlier when we had the serverless presentation, I was looking at it and I could see the shades of build pack in serverless, because what serverless is trying to do today, build pack has actually been doing that for years. And not just for one language or like one cloud provider, it's like fairly independent. So it has a lot of goodness, right? And it was really, really tightly coupled with Cloud Foundry per se, just the build packs. So based on the build packs, Pivotal in partnership with Heroku, actually made it into a CNCF offering called Cloud Native Build Packs. This is where it has become part of Cloud Native Compute Foundation, and it, instead of just building language-specific packaging, it is now an OCI image packager.
Oh, okay, that's
Or,
good.
as you may call it, a Docker image builder.
Yeah.
So this actually allows a much greater sort of deployment environment now. Anywhere you have a Docker, you can actually take the package that was built using Cloud Native Build Packs, and you can run it because it's nothing but a Docker image. Does that make sense?
Yeah.
So you can actually the package that actually gets built, it's a Docker image. So you can take the Docker image, you can run it locally as well. You can take the Docker image, you can push it to your registry, and then use it at any other remote location, right?
Yeah.
So what we did was the Cloud Native Build Packs, that is an open source offering. What we have done is we've actually added this whole service called Pivotal Build Service or Build Service, which has more enterprisey features. So first of all is the image promotion aspect. So think of it like this. When you are building an image for your dev environment, you run it through your dev environments, and once you are happy with the results, all your tests have actually passed, you want to now
Oh, that's good.
you want to promote it, and it will actually do that for you. The second thing it does is automated build image updates. So I'll come back to this slide, but I just wanted to show you. Okay, it's there in the demo, but the key here is when you're actually building an image, if you look at a Docker file, right? It has a base image,
Yep.
and then you have a set of instructions. Sorry, am I missing a slide here? Sorry, just give me a second. Somehow I feel I'm missing a slide here.
Pending public pending is already cancelled. Yes, surely.
Yeah, I think I must have deleted a slide here, but that's fine. I'll add it when I send the deck. Now, the behavior of Docker file also doesn't actually guarantee the consistency, because within your Docker file, you will have instructions to install certain artifacts like apt install if you're using Ubuntu, or if you're using Red Hat image as a base image, CentOS or something. You will have instructions to install certain dependencies, right? So the repeatableness is missing in that, right? So even if you base your image off of something, the repeatability is always missing. So that's where Cloud Native Build Pack, actually the build service, allows you to rebuild the image if any of your base images change without any intervention from the developer. So as part of build service, you just point your project configuration to a Git repository and a registry. And you say, from this Git repository, build the image and post it onto this particular registry. And you can do it without even writing a Docker file, because it will use the capabilities of build packs to identify what are the potential instructions for building this application into a Docker image. Your platform team can actually configure what build packs are usable by application teams. They can actually customize these build packs. So when there is a vulnerability, every application that has gone through this build service would be automatically updated. So the layer which is getting modified, let's say you're basing your application on a base image provided by Globe, and now there is a vulnerability that was discovered, maybe JDK or something.
Mm-hmm. Yeah,
What would happen is, platform team will modify, update, and push the base image. Build service will automatically find that, hey, I have so many applications that are depending on this base image. Let me go and rebuild all these images and push them into registry.
Okay.
If you find an application library dependency vulnerability, you can actually update that in your POM file or Gradle file. And the moment you commit it into your repository, again, build service kicks in and it will recompile your code and it will push. So both the layers that you don't have control over plus the layers that you do have control over would actually cause the image to be built and published. Is that something that is interesting?
Yeah. It's actually
Okay.
good because it's easier to roll out those kinds of scenarios that there are more affected images.
Yeah.
I can't imagine Docker doing that.
Yeah. So there is actually a link to the demo here. I could actually do the demo, but demo would take about 20 minutes. So there is a link to that. I have actually sent the slides over to, who did I send it to? I did send it to somebody actually. So have a look at the demo. It actually takes you through how you will work with the Pivotal build service. And it talks about both scenarios, application level vulnerability changes or application level updates, as well as a platform vulnerability update. It does both. So next thing, like if you remember in our model, we had a repository, right? Right here, we actually have a repository. So this repository, if you think about it, it is sitting absolutely next to your deployment environment. So what kind of protection can we think of in this step of our software supply chain? So if you think of it, when you're building a Docker image, right, you have a base image, and then that's wrong actually. That's not base image. That's just an image. You have a base image based on a Docker file. You create a new image and you push it to your registry, and from the registry, it's pulled and run as a container. That is the common flow, right?
Yep.
If you've ever used Docker, that is how it actually happens. If you are pulling something from Docker Hub, that registry is your Docker Hub.
Mm-hmm.
And these images, they are like pretty much sort of immutable, right? So you put it in dev, you do a test around it, then you put it in test environment, staging, and then prod. So you keep promoting these images across that. Based on what is the followed pattern within your organization, you might have certain variation of this, but pretty much this is the flow, right? And an image would comprise of operating system, dependencies, and applications, right? So far, you're with me on this?
Yes. Yeah.
There's nothing extra in images, right? It's pretty much that, right?
Yeah.
So first of all, as we spoke earlier, the build service, actually it gives you the consistent image. So the bottom two, the dependency and the operating system, would actually be taken care by the Pivotal build service. So you will have a consistent image that is built by the Pivotal build service. The image registry is not tightly coupled with build service. They are mutually exclusive. You can use one or the other or both, but not neither. So this is how typically you might have seen, like this is a sample Python server application. And what it basically does is that it pulls the Ubuntu image, it does install Python, and it runs, it adds the server.python under myapp/server.python.py. And as you can see, like from Ubuntu will actually not be consistent. Like it will try and pull the latest Ubuntu all the time, right? And the 14.4 or even that kind of a tagging will not help you. Correct? Because that's every time there's a new patch, whenever Ubuntu changes the image, you are on your own basically. It's their will, right? Even the APT is not consistent. It doesn't guarantee. And the server Python, that's questionable. Like whatever you built it on, that is what whatever is your current source version, that is actually getting pushed. It's not like based on certain tag in the registry or some repository or something, right? So this part is actually eliminated by the pivotal build service. And from the image registry perspective, at scale, if you're going to have like say 5 images, you can pretty much actually keep them on a dev server if you want, and you can run it. But if you want to run it across say Globe and have some consistency around it, this is how your flow would look like. You would have an image registry for your dev, an image registry for your staging, and an image registry for your production. And why would you segregate the registries? Can anybody think of an answer?
Sorry?
Why would you have like separate registries for each environment?
Okay, that's a good one. But I guess
Isolation.
yeah, isolation is probably one way.
Isolation is a very good reason to have something like this, right? The other thing is that when you're operating at scale, when you have like hundreds or thousands of automation scripts that are running, your CI/CD pipelines which are running, they can, and let's say if there is a misstep in the build, it can very easily overwhelm your registry as well, right? If you have like hundreds and hundreds of concurrent jobs which are running and producing thousands of images maybe, it can pretty easily overwhelm your registry. So isolation helps in that way. The second is that you may actually have the dev registry hosted outside, because let's say you are doing your CI/CD and registry and everything on the cloud, but your production images which are ready to be deployed in production are always on-prem. You can have that flexibility, but if you keep one single registry, you don't have that flexibility. The other thing which would be evident in a minute is these images may come with vulnerabilities. Like if you are basing your image on certain Docker Hub repository, it might have a vulnerability.
Not
But
might.
sorry,
It will.
Okay, it will have a vulnerability. Now, the question is, how do you even check for the vulnerability? If you've configured your systems to work against one registry, how do you get copy of that vulnerable image? Because a vulnerability could be like low, medium, or very high or critical, right? Probably you don't want any you want production, so maybe you say, you know what, I'm okay with the low and medium kind of vulnerabilities in my production environment, but the staging and dev can have even a slightly higher degree of vulnerabilities, because I just want to check that are these really vulnerable things. So even that is something that can be helped. So during your setup, you can configure your image registries in this fashion. The other thing is when you are actually managing image registries at scale, you need some role-based access controls on top of your image registry. So you're going to have many group of developers, many images, and you want guests can pull images, developers can only pull or push images in certain projects, and administrator can pull, push, or remove images. So something like that, right? So you need role-based access controls as well in your image registry. And since we are in a DevSecOps meetup, I'm sure security and verification is definitely there on the list, right, on the agenda. that is where the notary service comes in. So this is basically the provenance, right? Where the image actually originated from. For me to run a container, I should be able to actually get my image from a trusted source. The notary service basically allows you to sign the containers, sign the images that have been pushed into the registry, so that when you are actually running these images, you can verify them. It's cryptographically verifiable. So there is no way that somebody could get access into, say, a Docker environment or a Kubernetes environment, push something themselves directly and then run it there. Because you have the runtime protection of saying, only run images from this source, and not by just a name, cryptographically verifiable. And then I spoke briefly about the threats part, right? The vulnerability part. So when you push an image registry should be able to actually scan for vulnerabilities. These are the most common sort of databases where the vulnerabilities pertaining to containers or operating systems are published. So at the very least, I would want my image registry to look at all these things. Remember, we are still in the supply chain, the software supply chain. Image registry is part of it. Image registry is actually the supplier of artifacts to your production environments. It's like your last defense, if you come to think of it.
That's right.
So this is with all these things in mind, we have this Harbor image registry, which actually provides you with the ability to do the image scanning for all the vulnerabilities. It does it through a tool called Claire. It's an open source, open initiative, where all these published vulnerabilities are collected and distributed. So it keeps on updating its own internal vulnerability database and keeps on scanning all the images that have been pushed so far. So like the first image that might be existing in your repository would still be scanned to the latest one. So every time you push, the image gets scanned. Every time the vulnerability database is updated, it gets scanned again. And then it also has the notary service baked into it, which actually does the signing of your Docker images. So you can actually configure your runtime environments to trust this Harbor or notary service running inside the Harbor. It also provides you with the project construct, so you actually define your registries inside a project where you can set up the role-based access controls. And the last bit, the promotion part of it, right? We spoke briefly about it. It actually comes through the replication capabilities of Harbor. So you can actually replicate images that have been pushed into certain projects into a remote registry. So you can set up your CI/CD pipelines to say, you know what, I'm done with this particular image testing, all successful. Now take that image, push it into a second repository. From there, it will be replicated to your production repository, and it will be ready for your production deployment to kick in. If you want that manual control in your pipeline, saying, you know what, I want to be deploy this only on a manual function, sure, that manual function could be the trigger for replication.
Yogi, I have a question.
Yeah.
Harbor also applies to the build packs you mentioned earlier, right?
Yeah, so they are actually, I would say, complementary products. So your build packs will kick in first. So I mentioned about the role of, if you remember, sorry. Okay, it's here. So if you see here, build pack will pretty much be in this space. So the output of build pack would be this artifact, the Docker image. And your Harbor is the repository.
Nice.
So today you might be actually using say Docker build to build the Docker images, you can replace that with build packs. And I don't know what, do you use the Amazon ECR or something?
Yeah, I do actually.
Yeah. And you can actually replace that with Harbor, because obviously Harbor you can actually run within Globe. You don't need to run it only on Amazon.
Yep.
I mean, ECR you can't run on-prem.
Yeah.
So this thing is pretty much, platform independent. So with that, I've also actually put the video here. I think we are over time. So I've put the video for Harbor here. Do look at it. If you have more questions about it, when I get a chance to come down, hopefully soon, the coronavirus threat has died down. I would be happy to, even walk you through this in person.
Question. I have a question.
Sure.
I know that containers are pretty young right now. So is there I'm just curious if there's a security governing body who approves, the process of building and scanning containers currently?
So your question is there a governing body that does...
Say, for example, we want a security certification for the Harbor product, things like that. Is there a central governing body who does that certification or something?
CNCF is one body. I don't know what kind of certification you're looking for. CNCF is basically governing projects which are in the Kubernetes or the container space. So at the very least, for any product to be compliant in the Kubernetes ecosystem, it has to be approved by CNCF. So that is one.
So from a security perspective, not really from container, NIST as a framework, 801.90 about container security. It's more about the Kubernetes and all the ecosystem around. The security standard for anything that is container related. Just let's bear in mind it was written by the guys of Twistlock, so it's heavily loaded towards their product. But in absence of any other security standards, that's the closest you have.
So the NIST, specifically relating to the container security, this is one vulnerability database. It's generally accepted as the golden source, I would say. And Harbor actually uses this as well.
Okay.
Does that answer your question?
Yes.
Okay, great. Any other question? I'm actually done with my slides.
We should have done the other way around.
Yeah.
Because a lot of my principles rely on the fact that build packs, right? So when we were talking about, you mentioned about it works in dev, not in prod. Yeah. Build packs is one of the way we make sure that developers get production grade environment for development, so that you don't have this kind of bottlenecks down the line. We were talking about immutability and distributed. Yeah. The fact of making sure that you have the same containers along the line is enabled by build packs. So these are all of what Yogi mentioned are the building blocks that enable those new practices. So I should maybe have talked after you.
So see, one of the challenges in Pivotal Cloud Foundry, the Pivotal Application Services product, was that the containers were actually rebuilt for every environment. Okay, the droplets were rebuilt, although they were exactly same containers, but they were rebuilt. So that was one of the sort of challenges, and that's where the idea of cloud native build packs was born. But then when we saw the ecosystem at large around Kubernetes itself, that was basically the point where OCI image was taken as the native format for building these images out. So that, if you want to run it on, because Pivotal Application Services can run your Docker images, Kubernetes can run your Docker images, but Pivotal Container Service, Pivotal Application Service doesn't need a Docker image. You can just take your jar file and push it to the application server, the application service, and it will run it. It will create the container for you and everything. It can do all that. Whereas in Kubernetes, of course, you have to package it into, you have to package it into a Docker container. If you are into Spring Boot space, there is something that is hot off the press, which is Spring Boot 2.3.1, milestone 2, I think, which actually brings native support for build packs, basically. So if you go to start.spring.io, make a project with Spring 2.3, and what it will do is, it will actually give you a brand new command called Spring Boot : build image. And what that will do is, it will take your Java application without a Docker file and build it into a beautiful Docker image. And you could do it earlier as well, but now there's less for you to do. It's like how you need to worry about servers less in serverless. You have to worry less about Docker in a Docker image. All right. Any other questions?
Questions? We're good.
You're good.
Sorry, I ate into somebody else's time, I'm pretty sure.
That's fine.
Yeah, we're good.
Not as much as me.
All right. Thank you, guys. Have a good night.
Good night. Thank you so much.
See you soon.
Bye.
So guys,
This is Dennis. The video is here.
if you're okay with this kind of format, I think because we do have a lot of people in Singapore that has very good knowledge. If you don't mind this kind of format, I think we can help with this kind of meetups a little bit more easier. I mean, I'm not sure. So let us know. Like in terms of Spring, in terms of microservices design, I mean, unfortunately, I can't keep flying people in because they all have their respective areas. But I think we have pretty good experts in different areas, and I think we can definitely leverage on the pivotal team some of their experience. We don't mind that. If this is okay for you all in terms of clarity, we don't look too remote, then let us know. We are more than
Sure. We'll send you an email. We'll communicate with you.
Yeah.
And on our next meetup, maybe we can still invite you guys.
Yeah, if you want to talk about microservices, we'll get a guest speaker for microservices as well. Yeah. Okay.
Why are you looking at me?
I'm not looking at you. He will be the next speaker for Spring again. Yeah. Okay. Yeah.
You guys have a good one.
Bye.